Hi and welcome. Today we are going to look at stationary points and how to find their nature. We are going to be finding and determining the nature of the stationary points of the graph of y is equal to 3x cubed plus 6x squared plus 2x plus 1. Okay, first things first, what are stationary points and what does it mean to find the nature of them? Well, stationary points are points on the graph where the gradient is equal to 0. So, for example, these 2 points right here. The nature of the stationary points refers to the type of stationary point it is. There are a few possible ways a stationary point can occur. It can be a minimum point, a maximum point, or a point of inflection. Okay, so now that we know about stationary points, how should we go about solving this question? Well, the first logical step for us is to simply just find dy dx. Using the power rule, we know that the derivative of 3x cubed is just going to be 9x squared. The derivative of 6x squared is just going to be 12x. And the derivative of 2x is just 2. The derivative of 1 is 0 because 1 is a constant. Now, this next step right here is super important. Write this. At stationary points, dy dx is equal to 0. This shows that you have an understanding of how stationary points even come about in the first place. So, once we have this, we are going to be writing this thing. 9x squared plus 12x plus 2 is equal to 0. Let's just cheat and use our calculator to solve for this. So really quickly, in the actual exam, you need to write down the quadratic formula. I'm just going to skip that step and just tell you right away what the values of x are. So just give me a second. Okay. We have these two values. X is equal to negative 0.19526 and also x is equal to negative 1.1381. Both of these to 5 significant figures. Alright. Now we do want stationary points and not just the x-coordinate of where the stationary points are, so we do have to find out where the y-coordinate of these points are. So, when x is equal to negative 0.19526, y is equal to, you just sub it in. I'm just going to save you the trouble of that and tell you right away this is going to be about 0.816 to 3 significant figures. When x is equal to negative 1.1381, y is equals to whatever, which is just equals to 2.07 to 3 significant figures. Okay, so now we know the stationary points are going to be at negative 0.195, 0.816, and also negative 1.14, 2.07. The next thing that we have to do is to find the nature of these stationary points. To do so, we can use the second derivative test. The second derivative test implies that we have to take the second derivative. This is our first derivative right here. So we are going to have to differentiate it again. So how do we differentiate this? Well, the derivative of 9x squared is just going to be 18x. The derivative of 12x is just going to be 12. Alright, what do we need to do now? Well, we need to substitute the value of x into this and see whether d2y dx squared is greater or less than 0. So let's do that. This is going to be 18 times this. Which is about negative 3.5147 to 5 significant figures. And then for the other case, when x is negative 1.1381, well, that's going to be, oh, sorry, made an error, I forgot to add 12. There we go. This is 8.4853 to 5 significant figures. And for the other one, it's going to be negative 1.1381. This is going to be negative 8.4858 to 5 significant figures. Yeah, actually exactly. So there's that. Okay, what do these values mean? Let's say I have a graph of dy dx against x. If the graph is like this, it means that d2y dx squared must be greater than 0, because the gradient of this is going to be so. Let's try to plot a graph of y against x if this is the case. Well, we start off with a negative gradient, so it's probably sloping down, and to a point where it reaches 0, the gradient of 0, and then after that it's going to start increasing again. Something like this. So we can see that if d2y dx squared is greater than 0, this is a minimum point. Likewise, we can do something similar for the maximum. Something like this. In this case, d2y dx squared is less than 0. if this is the graph of dy dx against x, to plot a graph of y against x, initially there is a positive gradient which starts to become less and less steep, something like this, until it reaches a point when it's 0, and then it starts decreasing again. So it gets more and more steep like that. This means that if d2y dx squared is less than 0, this is a maximum point. Okay? We see that d2y dx squared for x equals negative 0.19526 is greater than 0. So this right here is a minimum point. While this, because it's negative, so the stationary points at x equals to negative 1.1381 is going to be a maximum point. So therefore, we can finally conclude that negative 0.195, 0.816 is a minimum point, while negative 1.14, 2.07 is a maximum point. And that's it. So thanks for watching, and I'll see you guys next time.